नाउ PQ, PQ वेक्टर क्या होगा? पोजीशन वेक्टर ऑफ Q माइनस पोजीशन वेक्टर ऑफ P. So 3 minus 3 minus 7 plus 8 minus 2 minus 1. Now we want to find the distance. क्या फॉर्मूला किया था हमने? B vector cross PQ vector upon magnitude of B vector. So what we want to find now? B vector cross PQ vector. I, J, K. Component of B vector 3 minus 1 5 0 1 minus 3. So I into 3 minus 5 plus J into 0 minus minus plus 9 K into 3 minus 0. So minus 2I plus 9J plus 3K. Now we want to find the magnitude of this. So magnitude of B vector cross PQ vector is minus 2 square, 9 square and 3 square. So 81 plus 13, 94. Now we want to find the value of magnitude of B vector. 3 square minus 1 square and 5 square. Square root of 35. So D is square root of 94 upon square root of 35. Vertices B and C of triangle ABC. Vertices B and C of triangle ABC lie along the line x plus 2 by 2, y minus 1 upon 1, z minus 0 upon 4. Find the area of triangle given that A has coordinates 1, minus 1, 2 and the line segment BC has length 5 units. Now, height h of triangle ABC is length of perpendicular drawn from point A. Point A से हमने perpendicular drawn किया h to the given line which passes through, the line passes through point, if we write it in general form, x minus x1 upon a, y minus y1 and z minus z1. So line passes through minus 2, 1 and 0 and is parallel to B vector, that is 2i plus j plus 4k, and parallel to B vector. So h is equals to, PA क्रॉस B जो हमने प्रीवियस एग्जांपल में किया था अपॉन मैग्नीट्यूड ऑफ B वेक्टर. The line passes through this point, that is minus 2, 1, 0. Now what we have to find? PA, position vector of A minus position vector of P. 1 plus 2, minus 1, minus 1, 2 minus 0. Now we want to find PA vector cross B vector. I, J and K. 3 minus 2, 2. B vector has value 2, 1, 4. I cap minus 8 minus 2 plus j, 2 into 2, 4 minus 12 plus k component is 3 minus minus plus 4. So minus 10i minus 8j plus 7k. Now magnitude of this PA vector 113. So square root of 213. Now magnitude of B vector, it has value 2 square, 1 square, 4 square, 21. So we get this as square root of 213 upon 21. 3 से कैंसिल हो जाएगा, 3 7. So 71 upon 7 square root. Now we want to find area of triangle ABC. Area of triangle ABC. Area of triangle is half base into height. 1/2 BC into H. BC की हमें लेंथ दी थी 5 units. H is 71 upon 7. So 5/2, 71/7 square units. Since this is area, so square units. Now the next is shortest distance between two lines. Shortest distance between two lines. If the two lines are skew lines mean they are neither intersecting or not parallel. Suppose these are two lines, they are neither intersecting not parallel. Then there exists only one point. यहाँ पे ये दोनों lines मिलेंगी, perpendicular होंगी. So this is the shortest distance. So this is the shortest distance between the two lines. This we want to find. If we have equation R1, R vector is equals to A1 plus lambda B1. This is line 1. Line 2 has equation A2 vector plus lambda B2 vector. Then the shortest distance between these two lines, that is equals to A2 minus A1 vector dot B1 cross B2 upon magnitude of B1 cross B2 vector. So this is the shortest distance between two lines. When the lines are given in Cartesian form, x minus x1, y minus y1, z minus z1 upon c1. Second line is x minus x2 upon a2, y minus y2 upon b2, z minus z2 upon c2. Then the shortest distance between these two lines is equals to x2 minus x1, y2 minus y1, z2 minus z1, a1 b1 c1, A2 B2 C2 upon square root of solving these two equations B1 C2 minus B2 C1 whole square plus A2 C1 minus A1 C2 whole square A1 B2 minus A2 B1 whole square. So this is the shortest distance between two lines when they are given in Cartesian form. Now next is shortest distance between two parallel lines. Shortest distance between two parallel lines. If two lines are parallel, then the shortest distance between them is A2 vector minus A1 cross B vector upon magnitude of B vector. Now using these formulas, we will have to find the shortest distance between lines. So let us start. equation a1 vector plus lambda b1 is equals to a2 vector plus mu b2. Now we know the shortest distance between the line is a2 minus a1 dot product with b1 cross b2 upon magnitude of b1 cross b2 vector. Now first we have to find a2 minus a1. a2 vector I minus j plus 2k minus a1. So 1 minus 4 minus 3 minus plus 2k. Now find b1 vector cross b2 vector. That is I j k. b1 is 1 2 minus 3 2 4 minus 5. So I cap is minus 10 minus plus 12 plus j minus 6 plus 5 plus k 4 minus 4. So we get 2i minus j plus 0k. Now find the magnitude of b1 vector cross b2 vector. 2 square minus 1 square 0 square square root of 5. Now what we want? a2 minus a1 dot b1 cross b2 minus 3i plus 0j plus 2k dot product with 2i minus j plus 0k. I component with I minus 6, j is 0, k is 0. So now we want the magnitude of this, so the term will be in positive, that is 6. Now shortest distance is 6 upon square root of 5. सबसे पहले हमने इक्वेशन को कंपेयर किया विद द जनरल इक्वेशन ऑफ लाइन इन वेक्टर्स a1 प्लस लैम्डा v1 a2 प्लस म्यू b2. यहाँ से हमारे पास a1 a2 b1 b2 की वैल्यू हमें मिल गई. Then a2 minus a1 vector b1 cross b2. Magnitude of b1 cross b2 dot product of a2 minus a1 with b1 cross b2. Then magnitude of that is positive value. So 6 upon square root of 5. Now the next is find the shortest distance between the lines x minus 1 upon 2, y minus 2 upon z minus 3 by 4. Another line is x minus 2 by 3, y minus 4 by 4, z minus 5 by 5. Now these are in the Cartesian form. So the formula is x2 minus x1, x2 minus x1, y2 minus y1, z2 minus z1. Now a1 b1 c1 a2 b2 c2 upon square root of 5 into 3 15 minus 16 whole square 12 minus 10 whole square plus 8 minus 9 whole square. So what we get here? 2 minus 1 5 2. So 2 3 4 3 4 5 upon square root of minus 1 square 2 square 1 square square root of 6. Solve the determinant 3 4 4 5 minus 2 2 3 4 5 plus 2 2 3 3 4 upon square root of 6. So what we get here? 15 minus 16 minus 2 5 into 2 10 minus 12 8 minus 9 upon square root of 6 minus 1 minus minus plus 4 minus 2 upon square root of 6 4 minus 3 1 upon square root of 6. So shortest distance between these lines are 1 upon square root of 6 units. Since it is a distance, so units. Compare these equation with general equation x minus x1 upon a1, y minus y y1 upon b1, z minus z1 upon c1, x minus x2 upon a2, y minus y2 upon b2, z minus z2 upon c2. Then we have the formula for shortest distance: x2 minus x1, y2 minus y1, z2 minus z1, a1 b1 c1, a2 b2 c2 upon b1 c2 minus c2 b1 whole square and so on. By computing the shortest distance, determine whether the following pair of lines intersect or not. R vector is I minus j plus lambda 2i plus k. R vector is 2i minus j plus mu I minus j minus k. Now compare it with general equation: a plus lambda b1, a2 plus mu b2. First we have to find a2 vector minus a1 vector. a2 vector is 2i minus j minus I minus j. So I minus j plus j is 0. Now b1 vector cross b2 vector. b1 is I j k, j component is 0, and b2 is 1 minus 1 minus 1. So 0 minus minus plus 1, j 1 minus minus plus 2 plus k minus 2 minus 0. So we get I plus 3j minus 2k. Now we have to find, by computing the shortest distance, determine whether the following pair of lines intersect or not. Now a2 minus a1 dot b1 cross b2. So I dot I plus 3j minus 2k. So we get I into I 1. If the dot product is equal to 0, then these lines intersect, otherwise not. Since this dot product is not equals to 0, therefore these lines do not intersect. Therefore, these lines, given lines, do not intersect. Shortest distance का formula use करते हुए prove करना है कि these lines intersect or not. Now next is next equation is x minus 1 upon 2, y plus 1 upon 3, z, x plus 1 upon 5, y minus 2 upon and z is equals to 2. Now इसे भी हमें प्रूव करना है कि ये इक्वल है 0 के या नहीं. Now these lines pass through 1 minus 1 0 and this line pass through minus 1 2 z minus 2 upon 1 and 2. First line pass through 1 minus 1 2 and the second line 1 minus 1 0, next pass through minus 1 2 and 2. Now the direction ratios of first line are 2 3 1, second line is 5. This is b1 vector, b2 vector, this is a1 and this is a2 vector. Clear? Now find the value of a2 vector minus a1. Minus 1 minus 1, 2 plus 1, 2 minus 0. Now b1 vector cross b2 vector, I, j and k, 2 3 1, 5 1 1. So 3 minus 1, 5 minus 2, 2 minus 15. So 2i plus 3j minus 13k. Now dot product a2 vector minus a1 dot b1 cross b2. minus 2i plus 3j plus 2k dot 2i plus 3j minus 13k minus 4, 3 into 3, 9 minus 26 minus 30 plus 9 minus 21, that is not equals to 0. Here we have 0. So the coordinates will change here. Z equals to 2 was the equation. So we get I 0 minus 1 j 1 into 5 2 into 0 k 2 into 1 minus 15. So minus I plus 5j minus 13k minus I plus 5j minus 13k minus minus plus 5 into 3 15 13 into 2 17 minus 26 minus 9 is not equals to 0. So these lines do not intersect. हमें कार्टेशियन फॉर्म गिवन थी, हम इसको